Good morning, everybody, and welcome to day 3 of the Nextflow and Nfcore online training that we're running in October 2022. My name is Phil Yules. I work at Secura Labs and I'm the lead developer advocate there. So my job is to look after the Nextflow and Nfcore communities and try and get as many people involved as possible and make sure that everything kind of works well with the community. Also a co-founder of the Nfcore community. So today's training is going to be a bit different to the last couple of days. Up until now, you've been doing a real kind of deep dive on how to write Nextflow code. It's more of like a kind of a code language tutorial and training. So hopefully you've got a really solid foundation on Nextflow itself. But today is going to be more talking about the community and talking about tooling and seeing about how you can be involved with an Nfcore, but also just use the Nfcore kind of tooling stuff. So just to give you a quick overview of what we're going to go through today, this is the schedule on the events page. So today I'm going to kick off with just a kind of some slides introducing Nfcore and what Nfcore is. I'm going to go through how to create pipelines and work with Nextflow schema and Nfcore schema. We're going to have a little break, and then Harshal Patel is going to take over from me. He's also one of the core team in Nfcore. And he's going to talk about DSL2 modules, which will make more sense at a later date. We're going to have another little break, and then Evan is going to come on, Evan, CEO of Secura, and going to talk about totally different topic, really. Going to come on and talk about Tower, Nextflow Tower, and how you can use Nextflow Tower to manage workflows. And so that's kind of a nice cap to the end of all this training. We're also on Slack answering any questions. So just as with the other days, same Slack channel, drop in there if you have any questions, drop in and say hi to introduce yourself to everybody. It's nice to see who else is kind of following the live streams. And as we go along, I'll try and do my best to respond. Plus we have a couple of guys on hand, Chris and James, who have been chatting with you yesterday and the day before, and they'll be able to help you with any questions. Right, so let's kick off. Okay, first quick recap. Nextflow, you guys covered all of this. It's a language, and it allows you to connect different processes within a workflow, stick them together with channels, and encapsulate this whole thing within one or more workflows. Hopefully you understand how processes and Nextflow allow you to have implicit parallelization. Also, Nextflow gives you the benefit of reentrancy, by which I mean you can resume the workflow and it will kind of jump back in where it left off and kind of cache all completed tasks in a smart way. And also give you reusability of your workflow. So you can reuse it again and again, tweak parameters to make it run in exactly how you want it to run each time. Nextflow itself is this language, and underneath that language, the runtime can manage the software stack for you and the compute stack for you. So handle all the software requirements using containerization, interact with all your different compute environments, submitting to cloud or cluster, and also manage sharing of the pipeline code itself to your code repository of choice. So you know all that. You've gone all that in lots of detail yesterday, and hopefully you're now totally sold on the fact that Nextflow is both reproducible, very, very highly reproducible, and highly portable. And that's why you're here. So if you've covered all that, what's the difference between Nextflow and Nfcore? Nfcore is kind of a sister project to Nextflow. The two projects are slightly distinct, although there's a lot of overlap between the two. And Nfcore we kicked off in around 2018 after one of the very first Nextflow user meetings or hackathons in Barcelona. And the idea behind Nfcore is that anyone can write a Nextflow pipeline however they like. It's a coding language at the end of the day. So although you can make pipelines highly reproducible, highly portable, you can also make pipelines not very portable. You can hard code all of your own personal file paths. You can use whatever unversioned software you like and things like this. So what Nfcore was started for was to try and establish a set of best practices for writing Nextflow pipelines and to try and form a community around sharing the development of those pipelines. Because Nextflow pipelines are so portable, it means that really for some of the first times in bioinformatics, you can share workflows around, different people can collaborate on the same set of code for workflows and actually form a community in this way. So that's what Nfcore is. There's a community around Nextflow, and we're focused on kind of extensional tooling and kind of content. So we provide there's kind of three main things we provide to people who get involved with Nfcore. The most obvious thing is we have pipelines. So off-the-shelf pipelines, which are ready to run your analysis with. You can jump in, see the pipelines we have, run them on your own data. You don't really need to know anything about Nextflow or Nextflow coding. You just jump in. We also provide a lot of kind of third-party tooling, as kind of how I call it. So those are tools both for people running pipelines and also developing pipelines to try and make that process easier, a bit more user-friendly, and also to have some of the Nfcore community-specific functionality in there. And finally, kind of a new one, first time I've had this on this slide, is we have modules and modularity and kind of pipeline components. And that's what Harshal is going to talk about a bit later today. Maybe if you're kind of familiar with some other workflow repositories, things like this, there's a few things to point out about how Nfcore is different. We are very, very strongly community focused, and that really means that we say, instead of coming with a pipeline you've written and adding it to Nfcore, you come with an idea for a pipeline, and then you develop it with the community. You propose the pipeline, hopefully before you even start coding, get feedback, maybe get collaborators at that early stage, and it's a community effort to develop a pipeline. Everyone must use the common Nfcore template, and that allows standardization and also allows some of the tooling, which I'll go through, like automatic synchronization, so that you receive updates to the boilerplate code, which are, again, collaborative and community driven. And everything is done through this collaborative code model on GitHub, where we use issues and we use pull requests and code reviews to ensure high quality. And this is the kind of a foundation of how the community works, as we rely on other people reviewing your code to make sure it works. So if you look at the pipelines we have in Nfcore today, as of last night, we have about 39, which have got kind of a green tick, which means they've got stable release. This is a special status for Nfcore. That first release in Nfcore pipeline has to get a really high level of review of the entire pipeline. And so that's a kind of our rubber stamp. We say that's our seal of approval. Once you have your first release, we are confident that this is a super stable best practice pipeline. We have another 24 pipelines under varying levels of development. Some of them are very early stages, but some of them are quite mature pipelines, which may already be in use in production, but they just haven't gone through that first release process yet, or are on their way there. And then we have 6 which are archived. So typically we never delete a pipeline, and we want it to stay around so that people can come back and rerun for reproducibility in the future. But maybe development on that pipeline has stopped for whatever reason, we archive it so that it's clear that development efforts should go elsewhere, and that one is now stale. So those are the off-the-shelf pipelines. In addition to those, we also have now modules, and these are these kind of components of pipelines. And to date, we have 632 modules, which is mind-blowing. And basically, each module corresponds to a single process that you've been doing in the past few days. So you had salmon index, for example, to create your reference genome index. That would be a module because it's a single process for a single task. And then you have salmon align, and that's another process. So that's another module wrapper. We're going to do a deep dive on these later, how to use them and how to create your own. But these modules, these DSL2 modules, are a real fantastically powerful addition to Nfcore. It means you can build a high quality workflow in minutes. And it also means that you can now collaborate with others, even beyond the pipeline level. But if there's different pipelines which share components, you can collaborate on that level as well. If there's a fix to a Picard mark duplicates module, then all of the pipelines using that can receive that fix, which is phenomenal. So if you go to the Nfcore Nfcore website, you'll see a big button that says pipelines, and you can search through all these different pipelines and see if there are any which kind of grab your attention. And I imagine that many of you will have hopefully already done this, probably part of the reason you're here. So in terms of the community itself, we kicked off in around 2018, and looking at the web traffic, you can sort of see a pretty linear growth in visitor numbers over that time. I was looking at this last night, and I think it's quite fun. You can see a couple of peaks in this plot. This one over just after 2021. I haven't completely sure what that is. I was wondering if it was the Nfcore paper, but now I'm looking at it and wondering if the time is wrong. So I'm not totally sure what that peak was. And there's another peak right on the far right. And that is you guys. That's this training, as we've seen a big bump in traffic to the Nfcore website. But you can see that as that scroll past, it's a real nice slow progression, and the community is just getting stronger and stronger the whole time. To date, we have just a little over 3,500 people on the Nfcore Slack. This is different to the Nextflow Slack, and is basically meant to be focused on the Nfcore pipelines rather than Nextflow syntax itself. We have close to 500 people within the Nfcore GitHub organization. And we have nearly 1,500 people who have actually actively contributed on GitHub, whether that be writing code or kind of creating issues to label bugs and discuss features and things. So these numbers, I have to refresh this slide every time I give a talk, because even a few weeks go past, there seems to be a significant bump. It's a massive community now, and this is really good for you guys, because it means whenever you run into trouble running a pipeline or doing any development work, you can hop onto Slack, and there's pretty much always someone around, even in the APAC time zone, and there's always people around to help and to test and to kind of get feedback on your work. And that's especially if you're kind of used to a fairly small bioinformatics communities. This is a real strength. And yeah, this is a map of kind of roughly showing our kind of global distribution again on web traffic. And this is something we're really kind of actively trying to push now, is global representation. Some of you may have seen Marcel speaking on Slack and giving one of the other training sessions. He's based in Brazil, so he's really focused on trying to improve our representation in South America. Chris, who was talking yesterday, is our kind of APAC representative, so is focused on you guys, trying to get everyone in Asia and Pacific up and running with Nextflow where possible. And we're really trying to kind of, through our Chan Zuckerberg initiative funding, really trying to push our inclusivity of the community. Right, I don't have a lot more to say before we get stuck into the real meat of this training. Just point out that we have a paper for Nfcore, there's a paper for Nextflow, and there's a paper for Nfcore. It's back in 2020 now, but it talks a little bit about kind of how we created the community, and especially if you dig into the longer supplemental methods, has lots of kind of background information about how we run everything and how we do everything within Nfcore, if you're interested. And with that, I think we can kick off. So today is a bit of a kind of step change. So the last couple of days, we've been following the Sakura training material for Nextflow with that same kind of long training document and with the same Gitpod environment. Today, we're following stuff purely for Nfcore. This is actually the first time we've run this particular training for Harshal and myself. We've done various training for Nfcore over the years, but this is the first time we've done this exact format. So you guys are the guinea pigs. And if you go to the Nfcore website, you can find there's a web page dedicated to all this content that we've been building up over the past days. So you can kind of follow what I'm doing. And if you missed anything I said or didn't understand something, you can see it written down. This is not a very friendly URL. Apologies for that. But if you pop over to the Nfcore website and go, you should be able to find the same URL through the documentation. So go to docs and then go down to tutorials. I've changed my screen resolution. It's dropped off the bottom. We need to fix that bug. But underneath tutorials, you should see one called Creating with Nfcore, and you'll get to this link. So this is all the different material we have here, and really the most important bit is this Launch Gitpod button. So if you click that, it will kick off Gitpod, and I've already got my workspace running, so it's telling me that I can use that there. And just the same as before, but you can see now we're basing the Gitpod image off a different repository, and we're doing that just to get the very latest version of the Nfcore tooling. because we actually did a release just a few hours ago. So for that bleeding edge copy, we need this different Git pod environment. So you start that, run it on the web browser if you like, or what I'm actually doing is I've got Git pod connected to my local VS Code installation. So I am sat here, yeah, still connected within VS Code and but running on Git pod, if that makes sense, which is how I like to do it. I'm going to drag that over here so I can follow my notes as I go along. Right. Hopefully that's a kind of good enough general intro. So let's kick off. First things first, hopefully now everyone can follow alongside me now. This is a vanilla Git pod environment. I haven't done anything to this after I clicked the Git pod button. And because of the way that we have Git pod configured, we've dropped into the tools, the Nfcore tools repository, which is useful if we wanted to develop code there, but that's not what we're doing today. So my suggestion, you don't have to do this, but my suggestion is that we start off with a fresh directory here. So the way I'm going to do that is I'm going to go to the home directory in Git pod. I'm going to make a new folder called training. I'm going to cd into that training. And then if I do find my current working directory, it's home Git pod training. And then I'm going to change this file explorer on the left. I don't really care about this directory, so I'm going to get a totally new one. So I'm going to go to file, add, no, not add folder, I want open folder. I did this in the web browser version, but I think it is shift and control O might do it. Yeah, open folder, there we go. It is, if you're in the web browser version, certainly there's an option in the drop-down menu, or you can get that keyboard combination, which was Shift Control O. It's also written down in the docs. Put in this path and hit OK, and then I think VS Code will refresh itself and sort of reopen with this new path on the left. And I'm going to say yes, I trust the authors because I wrote it, and there's nothing in here yet. And now the Explorer over on the left is completely empty because we're sat in an empty directory. Okay. So next thing, I don't really care about any file editors at the moment, so I'm just going to maximize the terminal window here. And now I'm running on the Git pod terminal via SSH. And final thing, if you spot anything, if you create files somehow and you're not appearing on the left, remember there's this little button here which will refresh the Explorer. So if you're confused, I had it once or twice that I ran various commands and files didn't immediately appear. And remember, you can hit that button if in doubt. So the Git pods environment comes with Nfcore pre-installed. So if you're using Git pod, you don't need to worry about installing Nextflow. You don't need to worry about installing Nextflow or Nfcore or any of these tools. You have everything you need already. If you're running on your own system at home, then you can find information in the docs about installing Nfcore. Nfcore tools is actually written in Python, unlike everything else you've done, and is sat on the Python project index here. So you can just do pip install Nfcore. It's also in Bioconda, so you can run it. You can install it off Bioconda if you want to as well. I would advise against using the Docker image of the Nfcore tools for now. Okay, so let's just double check we have Nfcore. So let's do Nfcore -- help, and this should give some output that looks a bit like this. So tells us that we're running Nfcore on which version we've got. 2.6 is the version that was released last night. So make sure that's the version you're running, because that's we pushed that out in a bit of a rush, partly because we are changing some of the ways that we're handling modules in DSL2, and we wanted to make sure we were showing you guys the latest, most up-to-date version. So so make sure you're running version 2.6, especially if you've already previously had this installed. And then we can see the different subcommands that come with Nfcore. So the help text here is grouped into kind of different sections, and there's commands for users. This is for people running Nextflow pipelines, which may be you, Nfcore or Nextflow. But Nfcore tools are designed primarily for Nfcore, but we hope that most commands run with most pipelines. So if you want to download a Nextflow workflow, you should be able to run an Nfcore download on your own custom Nextflow pipeline. It may not work super smoothly, but especially if you're using other Nfcore tooling like the template, it should work with any Nextflow GitHub repository. And the same goes also for launch and also for Nextflow schema stuff, which we'll be doing later. All of these toolings should work with any Nextflow pipeline, not just Nfcore workflows. So we can do, for example, Nfcore lists that will show us a list of all the available Nfcore pipelines. I've got the resolution set up really high, so it's not going to be very, very pretty. But this is basically a command line version of the website showing all the different pipelines. One nice thing about this as well is it also shows me if I have local copies of any of these pipelines. So if I do Nextflow pull Nfcore RNA-seq, or I could have done Nextflow run Nfcore RNA-seq, Nextflow will pull a copy of this pipeline from GitHub for me automatically and save it within the Nextflow cache. Now, if I do Nfcore list, you'll see that it says I have pulled this pipeline. I did it just now. It might say 2 weeks ago or something, and it checks whether the version I have locally is the same as the latest release. So it's just kind of a little bit of extra functionality because the command line tools know what I have on my local computer. Okay, the other big one I'm not going to talk about is Nfcore launch. If you're running Nextflow pipelines, I recommend you go and have a look. I wrote most of it, so I'm biased, but I think it's a really, really useful tool. It's either a command line wizard, which takes you through all the different parameters for your pipeline, whatever pipeline it is, and prompts you for things as you go along with embedded help text and validation of parameters. Or if you prefer, you can also launch that as a web graphical interface and fill in all of your parameters in a web form. It looks very similar to some of the interfaces within Tower, which Evan will talk about later, but this one runs purely on your own computer. The command line interface runs completely offline. It's just Nfcore here. So that's a nice, rich interface for launching workflows there. Anyway, you came here to write pipelines, so let's do that. We want this one, Nfcore create a new pipeline using Nfcore template. With any of these subcommands, you can also run -- help, so we can see all the different specific options and things for Nfcore create. But the Nfcore tooling mostly uses interactive prompting on the command line if you don't supply parameters. So if I don't give it a name on the command line, it will ask me for it. So generally, what I would recommend is just using Nfcore commands with as few command line options as possible if you're running interactively like I am here. So I'm going to do Nfcore create. And when it asks me here, prompts me for a workflow name, it does some validation as well here. So if I start typing my favorite workflow, then that's not a very good name for a workflow. And in fact, the Nfcore guidelines say that the workflow name has to be lowercase and without any punctuation, so just to prevent against that. So you can see there's kind of inbuilt validation here. So I'm going to call my workflow demo. Going to give it a little description. This is a new pipeline for training purposes, and my name is Phil Yules. This is a fairly new feature here. So if I select yes here, it will walk me through different parts of the Nfcore template, and I can switch them on and off. That can be the Nfcore branding, so I can generate a pipeline without any of the Nfcore logo and things. If you're never intending to submit your pipeline to Nfcore, it's so super bespoke and custom to your setup, it can be a good option. Also, if you're running a pipeline that's not genomics, then you can use this to strip out the parts of the pipeline which are parts of a template which are specific to genomics. So that's good if you're doing image or proteomics or ML or whatever. But for now, I'm just going to stick with the defaults. That's it. So it runs, it creates everything, a new pipeline called Nfcore demo. And it created this folder up here for the pipeline. And it reminds you, come and talk to the community before you start coding, because it's always good to get that sign off for a new Nfcore pipeline as early as possible. Okay, so if I do ls, you can see Nfcore demo. It's appeared in the file explorer up here as well. And you can see it's created a lot of files and a lot of code. So let's just quickly kind of have a quick poke around here. One of the first things to notice as well is that this isn't a flat kind of directory. This has actually initiated a GitHub, a Git repository. And if I do git status, you can see it's kind of a valid Git repo clone here. And if I do git branch, you can see it's even created 3 different Git branches. And these are the standard branch names that we use for all development within Nfcore. So typically, because if you do Nextflow run GitHub URL, it will run the default branch. And we want the default thing to be the latest stable release. So we use a branch called master for that, which should always be default. And that should always just have the latest release only. You don't do development work on that. Development work happens on the dev branch, and then the template branch you basically never touch. That's a special branch which is used for automatic synchronization of the underlying Nfcore template. And if I do git log, you can see that the creation tool actually made a commit of kind of the vanilla template, if you like. So it's the Nfcore template without any changes, and it's made that commit across all 3 branches. And this is for the automated synchronization. So if you create a pipeline and add it to Nfcore, if it's within the Nfcore template organization on GitHub, every time you do a new release of tools, you'll get an automated pull request coming to your pipeline with all the changes to the base code in the template. And that's what this is used for. If you're running a pipeline outside of Nfcore, you can still do that. And you can see down here, there's a command called Nfcore sync, and that uses this special branch, looks at the latest version of the template available, and will propose updates to your code to try and bring in all these fixes and stuff. So that's why Nfcore create does this. Note that if you're creating a new pipeline on a new repository on GitHub, GitHub will give you an option to like initialize it with a README and stuff. Make sure you don't do that, because we've got the initial commit here. So scroll down a bit. The documentation just under that, when you create a new repository, tells you how to do git remove add the GitHub URL, and then you can just push the commits that we have here already. Hopefully that makes sense. Right, there's too many files here to go through one by one right now, so I'll kind of leave that as an exercise to the reader to have a poke around. Many of these files you will never need to touch. There's things like, for example, gitpod config file. So if you want to launch gitpod and edit your stuff, and this tells gitpod how to run, you don't ever need to change that. Things like the code of conduct. If it's an Nfcore pipeline, you should never need to change this. But then a bunch of files should hopefully look familiar to you from the training you've already done. There's a main.nf file, which is kind of the main entrance point for the workflow. In Nfcore pipelines these days, the main nf file is very, very short. It just basically imports other files and runs them. You can see a config file here, which is very important. This is something you're going to have to do a lot of. And then up here, you can see we've got files for GitHub automation. We have assets, for example, the test sample sheet with the test data in there. We have custom scripts sitting in the bin directory. So we've got a Python script that we ship with the template to check the sample sheet for any inputs. And the conf directory here contains all of your Nextflow configuration. This is an important one. Again, the base config has all the defaults for all the different processes. So if you want to tweak how things are running, this is where you go. And if you want to tweak how the DSL2 modules are being run, then you do that in the modules.config. I think Harsha will talk through that later. Docs contains all the documentation. So this is your markdown file that hopefully you'll be developing and writing as you write the pipeline. Very important. And that will be rendered on the Nfcore website if it's an Nfcore pipeline. Lib you should never touch. That's just some helper functions that we bundle out the way. And then modules and sub workflows are everything that Harsha will talk about with modularization. And workflows is where the real meat of the workflow happens. If we look in demo.nf, you can see this is where all the actual channel handling goes on and importing the DSL2 modules. And this is where the real proper workflow building happens. Okay. First things first, before I start changing anything, I want to prove to you all that this is a valid Nextflow pipeline. I haven't touched any of this code yet. If I go up one directory and do Nextflow run, I can do Nfcore demo, which is the file path in this case. So when you do Nextflow run, it can be a remote repository name or it can be a local file path. I'm going to do profile, test, and Docker. So that will run using Docker, which I have installed in Gitpod, and it will use the test config profile, which and the Nextflow, the Nfcore template ships with this special config profile, and it knows what all the inputs are. It has some remote data that it will download and test automatically. You'll probably want to change this as you build your pipeline because it's very generic at the moment. But it's kind of how we always insist that you have a profile called test for automated runs. And then I'll do set an output directory for the results, which is where the published stuff goes to. So I'll call that test results. And if I hit run, you'll see that Nextflow kicks off. And we'll hopefully run our brand new demo pipeline without any errors. Fingers crossed. Nice. So you can see we're immediately getting a whole bunch of stuff from the template here. Got some nice Nfcore ASCII artwork to go at the top of your run. It tells you the version of the pipeline that we've created. So we start on version 1, but as you do new releases of your pipeline, then obviously you'll be bumping the version number here. It tells you some information about how we're running, like what directory we launched in, the directory that the pipeline itself is sat in. And these should look familiar to you over the last couple of days. Tells us about the input and output options that we've run with and our reference genome. Again, these are then configurable on pipeline level. And it tells us some of the other kind of core stuff here. This text at the top of the pipeline run when you run an Nfcore pipeline shows you the parameters which you have adjusted from the defaults. So this list will look slightly different every time you run, depending on how you're running. And here we can see it kicks off with, it's done a process to check that the input sample sheet looks good, which it did. It's run fastQC 4 times. It's a small desk data set, so it's already downloaded it and analyzed it. It runs this process, which is in special Nfcore one. So when we run tools within Nfcore workflows, we tell them to print their version number and we collect those. That means that we always get the accurate version number, even if you're using some other kind of software packaging. So we don't trust that the version is what we think it should be from a pipeline code. So we collect them dynamically and put them into a YAML file. And then all of that gets funneled into multi-QC. And if we look into test results up here, you can see we've got our output files. So we've got our nice multi-QC reports, we've got our fastQC analysis results, and we've got our Nextflow pipeline reports. Great, it works. You have your pipeline. Why did you need to do 2 days of training when you could just do that? Of course, this is where the fun begins. So although that's great, what you can see when I started looking through these files, it's kind of pretty overwhelming. There's thousands of lines of code here. How do you know where to start? You're not alone. We have some help here. So if I just pick the main workflow file here, demo, for those of you with kind of eagle eyes, you may have noticed that this line here popped out when I opened it before, and it's a special comments line. So it's highlighted because in VS Code, I have a plugin installed called To-Dos, which comes in the Gitpod environment, and it's highlighting it. So if I make it so it's not to do, it's not highlighted anymore. So it's just a regular code comment. And we have these scattered throughout the Nfcore template. And the idea is that they are like little flags telling you where to get started with customizing the template. So here it's telling us add all the file path parameters to the pipeline list. So, and as we scroll through, see if I chose a good example, I did not. As you look through the pipeline, you'll find these kind of to-do comments scattered all over the place, telling you kind of where to start and what to do. The reason I have this to-do plugin installed is because it's quite a nice way, actually, because it's a standard to-do comment. You can use plugins like this one to show you where all the to-do comments are, and you can just work your way through them all. So very easy to get started. A couple of other points about how we do coding within Nfcore. We love standardization. It's a really key thing. The template synchronization with Git works well if all the code looks as similar as possible. And also we're all about collaboration and contribution from many different people. And people write code in different ways, have different styles. Unfortunately, so one of the things we use a lot of is something called code linters. This may or may not be something you're familiar with from other projects, but if I pop into, what would be a good example? If I pop into the YAML file here, or that's not very full. If I pop into the README, oh, that seemed it. I've got a lot of Markdown file code here, and Markdown is pretty generous. I can remove that white space here. I can, what else can I do? I can kind of mess around with the Markdown in various different ways. For example, I can call that number 1 again. And this is valid Markdown. This will still render fine. There's no problem with this at all. But it's not very standardized. And so what we can do is we have a tool called Prettier, which is a linting tool. And Prettier works on YAML and JSON and Markdown and a few other languages. And we have other ones, for example, for Python code, we use Black, which is a kind of a standard one. And these tools check how the code is formatted and lint for it and have certain code rules. And they check that it's valid. And also you can have editor plugins which automatically update and correct the code based on those. So you see when I hit save here, hit save and the code updates itself automatically. I haven't done anything else. All I did was Command S there to save. It's added the spacing back in. So it's a standardized amount of white space around headings, and it's renumbered my Markdown list. And so this is really, really nice because it means all the code is really consistent. And once you get used to reading it, and once you start using these code linters, you'll never go back. But if you're new to it and you don't have them installed locally, you might find that when you push code to GitHub, you get kind of test errors saying that Prettier failed and linting failed. So don't worry if that's the case. All that's happened is this is just some kind of white space probably somewhere that needs just tidying up, and you need to run these tools. But I would definitely recommend getting these tools installed into your code editing environment. Be it VS Code or any of the others, they work against basically all the major editors so that you don't need to think about it, so that stuff just runs. So there are code linters, and we also have a linter specifically for Nfcore that we've written from scratch, which doesn't check the code formatting, the white space and everything so much, but it checks the Nfcore guidelines. And we have a whole load of automated tests in there which run through, look at your pipeline code and compare it to what we're expecting in the template and compare it against kind of predefined workflow rules and check that your pipeline is doing what we want. This is good for you because it means that you can get immediate feedback as you're writing your pipeline about whether stuff is correct or wrong. And it's also really good for anyone who's reviewing your code, who's reviewing your pipeline, because if all the Nfcore linting tests are passing off the bat, we know that the workflow is already in pretty good shape, and we just need to think about like more conceptually about what it's doing. So this helper tool is within Nfcore again, minus help. You can see it. It shows up here as Nfcore lint, and this is one you'll probably find yourself running a lot. So let's run Nfcore lint on our new pipeline. It does a bit of thinking on the back end, downloads some files that it needs to run comparisons and things, and then spits out a whole load of output onto the command line for us. Harsha will be talking about DSL2 modules. I'm going to ignore this section completely for now. But up here under pipeline level lint results, you can see we've got a whole load of pipeline test warnings. And you can see actually all of these are about those to-do comments that I talked about earlier. And so the point of this linting test is just to warn you that there are some still left in the workflow template, which you haven't yet addressed. So as you go through making those edits, just delete the to-do comments above it. And all of these test warnings will slowly start disappearing until eventually when you finish them all, they will all turn into passes. This number will be a bit higher and you won't have any warnings left. To prove this to you, I'm going to cheat horribly and do something you should never do, which is just change all of them without actually taking any action. So I'm doing a global find and replace here on the entire project. And I'm replacing all of these nice to-do comments with the text demo, just so that they're not found by the linter. Cool. Right, now if I run Nfcore lint again, it will run through the same kind of all the same tests here. It has a look, and sure enough, we've still got those module level pipelines, warnings, but the pipeline warnings have all gone. And it's gone from 178 up to 179 tests passed. Good. Hopefully that makes sense. Warnings are okay. Warnings, we try and get rid of all warnings when you do a release of your pipeline, because if it's all green across the board, then that's ideal. But warnings are okay; they're kind of tolerated; they're allowed. If you get failures, then that's less good. And if you have a failure on the Nfcore linting, then that needs to be resolved before you can merge your new code into the pipeline. I can demo this by just editing a file that I'm not meant to edit. It's the easiest way. So the code of conduct is one of the files where I said that you just shouldn't really ever touch. You shouldn't bother changing. It's the Nfcore code of conduct. So if I do change it, and then I rerun Nfcore linting, it's going to complain about it and tell me that I shouldn't have done that. And so now you can see that I have a test failure. It tells me what went wrong. And in this case, actually tells me I can automatically fix this by running this command. Each of the pipeline, the lint tests have a special name, files unchanged. And actually, if you alt-click on this, this is a hyperlink, even in the command line, thanks to the amazing Python-rich library. And so if I click that, let's see if it works within Gitpod. No. Okay, if I was running in a regular terminal, which is not within Gitpod, which is just on my local system, then this URL would open in a nice, very smooth way and take me directly to the documentation about this specific lint test. Let's see if I can quickly find it manually, just so you can see what it looks like. Tools docs, go to latest. These don't look super pretty yet, but will hopefully be improved in the near future. But it should give you a direct link to this page, and then you can see the documentation saying, with a list of these are all the files which must not be changed from the template. Some of the files mustn't be adjusted, but you can append additional content underneath at the bottom. So these ones you can stick more stuff into. And some of the files have, yeah, that's it. And there are other ones here. These are all the different lint tests here. So these are files which mustn't be deleted. This is how the multi-QC config should look. This is the one about the to-do comments. So all of these are documented here. But basically, you run Nfcore lint, and generally you just hit that link, and it will take you to documentation. Right. I said that you wouldn't be able to merge your code into your repository yet with its failing test. The reason for that is that we use extensively continuous integration. So if I go to the small RNA-seq pipeline, I'm going to pick on Alex because he won't mind. Then, here we go, yeah. So Alex here has created a pull request on the small RNA-seq pipeline within Nfcore. This is a long pull request, so we don't need to think about what he's actually doing here. But what is important is within this pull request, so pull request is how we merge code into a repository on GitHub. It's how we use our collaborative pipeline coding. We can all review other people's code through this interface before it gets merged. And you can see right at the bottom, and it says some checks were not successful. And you can see these are a list of automated tests which ran on the code that he pushed. And some of them have got a green tick, so that Nfcore linting, which we were just talking about, did actually pass here, but some other tests failed. And because these have a red cross, this pull request cannot and should not be merged until that is resolved. If you click on the details next to any of these, it will take you to a web page showing you exactly what happened. And this is the Nfcore run. If I click here, it shows the actual Nfcore lint run. And here is the exact same output running Nfcore lint. And you can see what the warnings were, what the failures were, and everything, exactly as if you were running locally. So this is the real power of this tool, is that when you create a new pull request and someone else comes in to look at it, if there's a little green tick there, they know that everything within the pipeline is up to Nfcore standards. Final touch on linting. Maybe you are building your own pipeline, which is never going to be part of Nfcore, and you don't care whether it has the Nfcore logo properly formatted, or you don't care about having the same code of conduct as us because you're not part of Nfcore, or any number of reasons. For any Nfcore lint tests, you might have a reason why actually you're okay with that failing. So you still want to be able to use this tooling. You still want to be able to use a continuous integration on wherever you have your pipeline. How do you get around that? And you can see that there's a counter here for number of tests ignored, and that's the key. If you go into the config file, we're at the base of any Nfcore pipeline called nfcore.yaml. It's pretty empty from a template. It just says that this is a repo, but you can go in and add to this file scope lint, and then you can give the name of any lint test. This is the same as the name which was shown on the left here. So files unchanged is the name of a lint test. I have files unchanged. I could just set it to false to completely disable this test. But with certain specific tests, this one included, I can actually give it a list to give more fine-grained control and say, actually, I only want to ignore this file. I still want to pick up any other files that have been changed. But I could set this to false to skip the entire lint test. If I save this, come down here and rerun nfcore lint, then hopefully everything will pass again. And now we have 2 pipeline tests ignored, so it's just telling me that I've ignored something, but the failure has gone. We have 0 tests failed, and we're good to go. Right, how are we doing? Hopefully everyone is still with me at this point. The final thing I'm going to talk about before I stop is Nextflow schema. Nextflow schema is something that started off within Nfcore, which is why it's part of this demo. It's part of all the Nfcore tooling, but it can be used with any Nextflow pipeline. So what the stuff I'm going to talk about now is also valid for all the training examples you did yesterday. Any Nextflow pipeline you write should work with Nextflow schema and should work with the commands I'm going to show you. But it's just a historical fact that it comes from Nfcore originally, which is why it's called Nfcore schema and why you need the Nfcore tooling. So if I go back up a level, oops. Before I ran the Nextflow pipeline, right, I did Nextflow run Nfcore test, Nfcore demo. With any Nfcore pipeline, you can run a workflow with -- help, the same as you would with any other command line tool. And Nextflow will run the pipeline, but it will just exit immediately and print some help text to the command line, which is kind of just nice and easy for you. And so when I do that, you can see it prints out all the different parameter options which are typically used. And it even it hides the load by default, which are kind of the boilerplate ones. We don't have very many here because I haven't added anything yet. But you can see that if I do add show hidden params, that the pipeline comes with this huge list of different Nextflow parameters for configuring all these different aspects of a pipeline. Now, something you might notice is that this help text includes a couple of things which haven't previously been possible to save up until this point. It tells us that these parameters should be strings for starters, whereas this one is a Boolean, a true false. And it tells us that this one should be an integer. So within this help text, we have parameter variable typing information, and we also have help text. This is currently not possible to do within a Nextflow config file. You can't add this information there. That might change in the future, but for now, there is no way to have this within Nextflow config. So the way we do this is that we basically created our own new standard. If you look within the pipeline source code here, you'll find a file called nextflow_schema, and it's a JSON file. And we can look in here, and it has a list of all the different parameters within the pipeline here. This is -- input, and it has this information. It says it's a string. It says that here's your description, which is kind of the help text, or it's got help text and description. So that's a short help text, that's a long help text, which could be written in Markdown. And it has a bunch of extra keys here to help configure how these parameters are handled. This has a bunch of good things about it. This lets us do various things. It lets us print help text to the command line that you just saw. It also lets us render the same information within a web UI. So if I go to the RNA-seq pipeline page on the Nfcore website, you can see there's a tab saying parameters. There's this for every single Nfcore pipeline. And it prints some really nice help text here. This is all based off that JSON file. We've got the input, we've got the type, we've got the description, and we've got the longer help text. So it allows us to render this kind of rich help text wherever you want. There's also a command line option for doing pretty much the same thing if you'd like, so printing markdown. And it lets us validate the pipeline inputs, which is really, really important. So if I do Nextflow run again, I'm going to go to the previous command here, so down at the bottom of the screen, where I did Nextflow run, I did -profile test docker. And when I ran that before, I specified the output directory. And outdir is a required parameter in the Nextflow schema. So if I delete that and try and run again, Nextflow will run the pipeline, but the very first thing it does is it checks all the parameters against this JSON file with some custom code, and it will immediately spot that our required parameter is missing and throw an error and not launch at all and just exit. So it fails quickly, which is really important for long-running processes. So it allows us to do validation, and finally, it allows us to build nice, rich interfaces. I can do Nfcore launch, that command I told you about earlier, and it looks at this pipeline and it says, great, I found a Nextflow schema, and I can give you a user-friendly graphical interface to do that. I can do that either by launching a web-based interface, or you can do it on the command line. And here it takes us through all the different parameters. It tells us which ones are required. It won't let us continue because it does validation as we go along, and it has all the help text and everything. So all of these rich interfaces are based on top of that JSON file. That's great, but if you started to panic a little bit when you saw this JSON file and imagined trying to edit it, you're not alone. You should never touch this file by hand. You will almost certainly break it. I do every time I try. It's very long, it's quite complex, and especially as you build more and more parameters into your workflow, it will get longer and longer and longer. So you shouldn't ever touch this JSON file manually. But what we do have is we have a tooling called Nfcore Schema, which helps you to work with this. I need to speed up a little bit. So if I go into Nextflow config file, I can put in some additional parameters here. So I'm going to drop some new custom params in. There we go. And then if I run Nextflow schema builds, which I can run as many times as I like at any point, it looks at the Nextflow config and it prints all the different parameters from Nextflow itself. And it looks at the current Nextflow schema file, and it says, hang on, there's a new parameter here that you've added and I don't recognize it. Do you want to add it to the pipeline schema file? Similarly, if you rename something or deleted a parameter and it was still in a JSON file, it would prompt you to say, do you want to remove it? So I'm going to add my new parameters here. And then it's rewritten the JSON file now. So it's updated it with and added the new pipelines. That's done automatically, but we probably want to customize it to make it nicer. And so it says, do I want to launch the web builder for customization? And yes, I do. Right. This is a weird thing with Gitpod. Normally, when you do that, it will kick off a new browser tab on your computer with the editor. But because we're in Gitpod and Gitpod doesn't know about web browsers and stuff, it uses a command line based web browser called Lynx. And that's quite confusing. So I'm going to press Q and it says, are you sure you want to quit? And I'm going to say yes. Thankfully, our tool is still running in the background. So normally you'd never see that unless you're running on Gitpod. And thankfully, it prints the URL to the screen here. So this is what would be loaded normally. Right. So, and this is our nice graphical interface for customizing Nextflow schema. And here you can see all of the different parameters and all the different help text and everything in this kind of rich interface. If I collapse all the groups, so grouping is another kind of idea that comes from Nextflow schema. It's not within Nextflow itself. You can see the new parameters which are added automatically and they're sat at the bottom and they're ungrouped. So what I can do is I can add a new group. And I can drag and drop these things around. Oops. So I can, or it's a bit complaining on my small resolution. Or it's just not going to work for me. Live demo. Here we go. Managed to get it down. So we've got a new group down here, and I can drag stuff into that new group. Or if I've got a lot to do, I can click this button and select all of the ungrouped parameters and move them all in one go. So our new parameters are now within this group, and I can set an icon. So I can say, this is got a little picture of a hand, and I can write, this is a group of parameters. And then for each parameter I can go through, I can set an icon, which is used on the launch interfaces, the web interfaces. So I can pick a test tube for that one. I can pick, I don't know, a cog for this one. Bar, let's do some weights. Whatever kind of makes sense for your pipeline, for your parameters. You can see most of these ones which we already have kind of slightly more logical icon set. Then I can write a short description here, and I can set the type. This one is clearly meant to be a Boolean. It's the default set to false, so I can click on that and select Boolean. And this one, it's guessed should be an integer, so it's already set that to integer for me. I can get rid of null values there. I can tick if I want something to be required, so that it would throw an error if it's not specified. And I can click on this to write longer form help text. And anyone who's used to writing Markdown on GitHub, this will feel familiar. I can write some help text here. And click preview, and you can see that this is what it will look like when I do help text on the command line, and this is what it will look like on the website. It's not rendered as Markdown. Okay, but on the website, it renders it as Markdown. Take my word for it. Importantly, then, final thing on here is we have a little cog for additional settings. This lets us do extra special stuff, and it's what we see here is based on the variable type. If it's a Boolean, we can't really do very much, so there's nothing there. If it's an integer, we can set a minimum and a maximum, or a float number, and we can set a list of enumerated values, so the user has to pick from 2, 4, 6, or 8, and if they enter anything else, it will throw an error. If it's a string, okay, it's complained because I said that I had to pick from these numbers, and the default wasn't one of those numbers. If it's a string, I have the most options of all, so I can set enumerated values again. And I have to do it with a pipe character, not a comma, apologies. I can set a regular expression for a string, which the input must match, else it'll throw a validation. So the example here is if I wanted to do a .csv file, then I can say that the input parameter must end with .csv. And specifically when inputting files, for example, sample sheet CSV files and things, I can set here the format. This is very new. And I can say it must be a directory or path, which could be either or a file path. If I select file path, I have additional fields here, and I can say that this is a CSV file. So if you click this link, it will show you a big, massive list of all the different standard MIME types. So I can type in text CSV, and I can even set downstream schema, which I'm not going to touch on because that's very new and not very well supported yet. But this bit is really important, especially if you're running on Tower or if you're running on some other tool which has rich kind of input forms, because this tells that tool through the JSON file that this isn't just a string, this is actually a file, and the file should look like this. And this then allows rich interfaces to be built around that. Right. If I just minimize my windows here, you will see that the console is still running in the background the whole time while I've been sat here. So it's still, that little spinner is still going round and round and round, and it's just waiting for me to hit save. And I think this is really fun to show it at the same time. So if I'm on the web browser here, this is on the Nfcore website, but I'm done. I click finished, it saves it, and boom, the command line in the background saw that I saved my file, and it has saved everything into the JSON file. If I go up one now and rerun the help commands, minus help, we should see our new parameters that we added with their nice help text and everything showing that the schema is doing its job properly. Sure enough, demo group, string, Boolean, integer, defaults, and everything there. So great, that's worked perfectly. And you can rerun Nfcore schema build as many times as you want. Do a little bit of editing, click finish, come back, run it again, do a bit more, tweak, change, add parameters, remove parameters, just rerun it whenever anything to do with your config changes and play around with it and customize it as much as you can, because that gives a good interface for people using your pipeline. Right, with that, I'm going to stop. We're going to have a quick break, not very long, because I think I probably ran over a little bit. And that's me finished for today. Please shout with any questions you have on Nfcore Slack. I will jump in and try and help, as well as our helpers, who are doing a brilliant job, I'm sure, of answering all of your questions. And in a few minutes, Harshal will jump in and start talking to you about DSL2 pipelines and all the power of collaboration that they bring. Thanks very much for your attention so far, and I'll chat to you on Slack. Thanks, everyone.
Hi guys, welcome to the Nfcore training for today. It's nice, cold, and dark in England at the moment at 4 or 5 a.m. in the morning. Hope you all are doing well. Phil and I and a bunch of others had a bit of a late night trying to get all of this together yesterday in preparation for the hackathon and a bunch of other stuff that we need to sort out. So if anything breaks, then blame Phil because it's always his fault. So I'm going to try and give you an overview of Nfcore modules and how we are using them now, especially in the context of Nextflow DSL2. And so Nfcore modules initially was started off to be a repository where we can share these modules across the Nextflow community. Maybe I should introduce myself first. I'm Harshal Patel. I'm head of scientific development at Secure Labs, and so I've also been a long-term contributor to Nfcore since the very beginning, pretty much, as well as to the Nextflow community. So yeah, we're doing really cool stuff at Secure Labs, and it's great to be able to still be here and contribute and do all of these really cool open source things in the community as well with Nfcore. It's an awesome community, as Phil probably introduced earlier, and we're growing rapidly. And so as a result of that, we are starting to collect a set of best practice pipelines on Nfcore. We're hitting almost 60, 70 pipelines now. And we need to be able to share functionality across pipelines. So if you look at this particular tube map here, this is for the RNA-seq pipeline. You can see there's routes through this pipeline that could potentially be shared in other pipelines. So there's modules like FastQC, Trim Galore, MultiQC even, and others that won't just be used in a single pipeline. And with Nextflow DSL1, everything was kind of monolithic in that you had to put everything in the same script. If you wanted to use the same process more than once, you had to physically copy it into the main script. Whereas with the implementation of Nextflow DSL2, what that allows you to do is to reuse these components within the same workflow and across workflows. And so just a brief sort of crash course into the terminology that we defined as soon as we started working with modules is that a module is a unit of Nextflow. And so it's a single process that does and performs a specific task in a containerized job. So say, for example, FastQC, that's one process that performs a particular task. That is what we would call a module. Similarly, you may have tools with subcommands like samtools index. And so that also is potentially what we would call a single tool, a single command. Now, these modules can also be chained together. So there may be bits of functionality in your pipeline where you want to run samtools sort, samtools index, and then maybe samtools stats and so on. And this particular sub workflow, which is what we call it, could be used in other portions of the pipeline as well, because you may want to sort a BAM file multiple times in the workflow. And this is really where the strength of DSL2 comes in, because not only can you reuse the same components within the same pipeline, you can reuse them across pipelines. And so this is why it became very appealing to us to really start working on this and setting up the infrastructure where we can share these modules across pipelines. A workflow is just an end-to-end pipeline, and so that in itself will be composed of modules and sub-workflows. And so an end-to-end pipeline would be like the Nfcore RNA-seq pipeline that runs a particular workflow. I won't go into much detail about this stuff, but we had long drawn-out conversations about exactly what and how we go about implementing Nfcore modules. We love automation. We need the pipelines to be portable for them to work for as many people as possible out of the box. They need to be practical. People need to be able to contribute these modules if they can, and also flexible so that other people can install them in their workflows and use them straight away. They need to be reproducible. Again, very key to any sort of Nextflow pipeline development and science in general to get the same results. we need to have documentation for these modules as well. And we need to be able to standardize them. So you don't see 50 different modules looking in different ways and stuff. We need to have lint tests and ways we can check this over time to make sure that everything looks the same. And also this just makes it easier to update everything, which is what we've done the day before or something like that. If we're using the same syntax, the same standards and all of that sort of stuff, then it makes it easier to roll out these sorts of updates without having lots of things in a repository that look completely different to each other. So in terms of how this all started, we started having conversations in July 2019 when Paolo was toying with DSL2 and really coming out with some good preview versions of DSL2. And so I initially created this repository at ISMB in 2019, thinking that we need to do something. And if it's there, we will do something. But it turned out that just got distracted. I got distracted and we didn't touch it for a while. We had a few sprints in between at the Crick Hackathon in person, which was the last one before the pandemic. We managed to squeeze that just in. And then since then, we've been mainly having remote hackathons. So we had one at Cubic, where we again made a bit of a dent, but we needed a proof of concept. We needed something that we could use to then really roll out modules across Nfcore. And so at that time, the RNA-seq pipeline needed a bit of love. It was still DSL1, and we've had various people that have been working on that pipeline, and this is one of the testaments of having it in on GitHub that other people can take over. It's not just, the pipeline doesn't die with the biometician in-house when they leave, for example. And so I picked up the pipeline and I went about converting it to DSL2. And through various iterations of updates and changes and the syntax adaptations, I kind of knew where we wanted to go, but I didn't anticipate where we would end up. And so the only way you can really go about doing that is making changes and more changes and more changes, asking questions from the community, getting opinions, and then asking others to use it, and then eventually you refine what you had initially. And so we went about doing that, and then in December, we added this to the pipeline template. We decided we wanted to switch all pipelines to DSL2. And in March 2021, the 45-ish modules that I added initially from the RNA-seq pipeline then became 105 within a few months as people started picking it up. So we almost doubled within the space of a few months of these different modules for these mainstream tools like FastQC, SAM tools, and so on. We added CI tests to make sure they work all of the time, as well as test data to make sure they work as well. And then we also went about trying to add commands to Nfcore tools, which is the Python package Phil introduced, where we can really attempt to automate some of this stuff and standardize how we use these modules. Today, from 105, we now have 632 modules, which is phenomenal. The community is active, very active in terms of adding these modules for their own use, for general use. And we've now also got sort of 150 contributors that have contributed now to date to Nfcore modules. So it's really growing, and there are people coming in from outside the community just to adopt the standards we're using, even forking Nfcore modules, because these modules are tested, they work, we've got CI tests. And so they're very appealing just to start straight away to constructing pipelines in your own settings. We keep them up to date with best practice. There may be breaking changes every now and then, but I promise you it's not because we want to, it's basically because we've been backed in the corner and need to make them. So apologies if that's broken anything for you. We have a massive toolkit that we've built up around the GitHub API, and we've got sub workflows coming soon. In fact, that will be probably one of the main focuses of the hackathon next week. So rather than just installing single modules in your pipeline, we'll have additional tools in Nfcore tools and proof of concepts that we've already added that allow you to now install entire sub workflows into your pipeline. So you get a chunk of functionality rather than just a single module. There was various things that I think I won't go into this much detail, but there's various things that were important, especially when I started out writing and developing this. And one of those was the ability to overwrite non-mandatory arguments, because it would have been nice for these tools to be as flexible as possible to the end user, rather than having hard-coded parameters in the module that are very difficult to change once they've been added to the pipeline. I wanted to have something where end users could add their own non-mandatory options or change these non-mandatory options if and when they needed to tweak the behavior of the pipeline. Now, what that means is that rather than creating another release specifically to accommodate these different parameters, you now have the option of using exactly the same release, but just tweaking the non-mandatory parameters for your particular use case. And that's been really nice because it's just meant that we've been able to reuse the same pipelines with just by providing an additional configuration file. So you can see at the top there, if you wanted to change for the trim galore module in the RNA-seq pipeline, you wanted to add an additional non-mandatory argument, it's pretty simple to do that. But as I mentioned, I won't go into much detail. You can also change resource requirements and container definitions as well with this sort of thing. We've got a massive toolkit that I'm going to demo to you now and hopefully show you the utility of all of this and how useful it can be when interacting with modules. And there's a bunch of resources. So hopefully, I think these slides will become available when the training's finished. We'll put them up on the website. And so these links should work. You can click on them and there's a bunch of resources here, hopefully to cover what I haven't. And yeah, you can find us on all of these different communication channels. And I'm going to say thank you in advance so I can get out this slide deck and find the terminal. So let's close that. And so now I'm going to jump straight into the demo. Hope you guys can see my screen, or I've got a split screen with the Nfcore website and Nfcore tools repo. And so what I'll do now is, so that document that Phil was going through earlier is what we'll go through as well. So if you go to the Nfcore website, let me make this bigger. If we go to the Nfcore website, and go to docs, and then come down, and then go to contributing. Oh, is at the bottom of my screen? Oh, it's the nabs at the bottom. Sorry, didn't see that. And then create. No, sorry. Tutorials, creating pipelines with Nfcore. So this is what Phil was going through earlier, and I'm basically going to try and do the same thing. And so in my other tab, I'm going to load up a Git pod environment. So I've just come to the Nfcore tools, GitHub. I'm going to create a Git pod environment that we can use. Just find a section. So we'll be going through this Nfcore modules section. I'm going to do this directly in the browser. So let Git pod just warm up. It's quite early in the morning. And so now you can see you've got Nfcore tools installed here. And so I'm just going to create a pipeline quickly, like build it. Maybe if I come out here into the top level directory and run Nfcore create. Customize the template. Oh. It's a little bit bigger, just in case you can see it. So now I've got this demo pipeline that I've built in seconds, and I will now open that folder so we can see what's in it. Take it back out, so I'll just cancel that and open it in the browser again. And so now you can see the top level directory here is this Nfcore demo pipeline that we've just created. So what I'm going to do here is show you how we can use modules. So I'm quickly going to run an Nfcore lint. And so the linting checks that everything looks okay. There's these to-do strings that Phil mentioned in his talk that you can start to adjust and get rid of eventually as you amend this pipeline. As you run the lint and you remove these to-do strings, they'll disappear from these warnings. This is something we need to fix, and we'll probably fix in the next release to get rid of this warning. So now what we need to do here is you can see that to add a workflow, to add a process to the main workflow, the way things are organized here is that you have workflows, sub-workflows, and modules. So this is what I introduced earlier in terms of the terminology. The workflows, this is an end-to-end workflow. Sub-workflow is just a chain of modules. These are the modules here can either be local to the pipeline, so something that's specific that you need that doesn't necessarily belong in another pipeline. You can keep them in this local folder. And then you have others like these that have been installed from Nfcore modules, for example, MultiQC, FastQC, and a couple of others. So let's try and add a process to the pipeline template, the vanilla pipeline template. We'll go to this demo.nf file, which is the main script that we're actually executing here. And I will copy in that process here. In fact, let's run the workflow as it is. Tell me what's running. Nextflow run .file Docker. Give an output directory. And that should take a couple of seconds. So what this is doing is it's running Nextflow. The dot here is just it's running in the current directory, so it picks up the main script and runs that automatically. And then it will run to the test profile in this particular pipeline, which has a minimal test data set of FastQ files by default. And it will use Docker to run as a containerization engine. Any published results will be put in this output directory called test results. And so this will take a second or two to finish. You can see all the parameters that have been dumped here to screen to show you exactly what you set when you run this pipeline, which is pretty nice because it saves you having to look at logs and other stuff. It just shows you directly which parameters you changed compared to the defaults when running this pipeline. So as that tags along, maybe I'll talk to you about so I'm just going to revert back to a single screen. So I'm going to just shift this here. You guys can follow along as part of the training online. And so I'm going to make this slightly bigger so you can see what's going on. Sorry, just a second. I'm going to stop sharing and move this across to make it easier for you guys to see what's going on. All right. Is that better, guys, on the inside? Sweet. Okay, cool. All right. So you guys can follow along on the website as I do this. I thought it would be nice to do it side by side, but if it's difficult to read, then there's no point in doing it that way. Okay, so our pipeline is now finished. This is the vanilla pipeline, so it's working out of the box that we've just created. And now we want to add a process in. And so this process, all it's doing really, it's taking the output, or it will take the output of this input check reads channel, which we can view to see what it looks like. Resume. I'm just going to tag resume on the end, so it only reruns processes that aren't required to be cached. And so now what should happen is the contents of this channel should be dumped to screen here, and that will show us how we need to configure this echo process to take as input. So here you can see when you view the channel, you've got this meta map at the beginning, which just contains, it's like a Python dictionary, but in Groovy, that contains an ID, whether the sample is single end or not, and the path to the FASTQ files. And so this echo process here is now taking as input the channel of the same structure, which is the meta map and the reads, and it's just going to print the reads to screen. And so here, if I resume the pipeline now, I've uncommented this, nothing should happen because I've just copied the process in. We actually need to invoke the process in the main workflow. And so we go further down in that document. Yeah, so this will just cache. This will just run the pipeline as it is. And now if we want to invoke this process, we actually have to stitch it up in the pipeline. So here under the FastQC, what I'll do is I'll call the process that we've added here, and it will take the output of this input check process and just echo the paths to the reads to terminal. There you go. So this is just a simple process. It's just to highlight how you can add processes to the existing pipeline template. Now, say you wanted to add a module. Let's create a module and move that process across. Instead of having the process directly in the main script, it's much nicer to have. So let's create a module. It's much nicer to import it from somewhere else, and then you can reuse it multiple times. So I'm just going to create a local module here. I'm going to cut this out, paste it in here, save the file, come back here. So, but now that I've pasted it into this external file, I need to now tell Nextflow where that process sits. And so what you can do is have another include statement now that is including that process from that particular module that we've just created. And so now, if we resume, that process is not coming from the main script, it's coming from that local module. So the behavior here is we still should see the files printed to screen as we were before, but the module is actually being called from a different location. There we go. So that should finish in a second. But now the true strength of DSL2, as I mentioned earlier, is that you can reuse these modules. And so you can call this same module more than once. And so what you can do is you can alias that module. So I'm going to remove that initial call, and I'm going to call or import this particular module with different names. And so what we can do here with minimal adjustment is just rename to whatever we used here. So you can reuse the channels and so on. So here I'm just going to change that twice. So now we're invoking this process more than once. And so what should happen here is that the file should be printed twice instead of once now, because we're calling the same process more than once, and it's exactly the same process. We're not having to change it. So you can have this similar sort of behavior with sub workflows as well. And you can import these modules in the same pipeline or different pipelines. And so here you can see that now these FASTQ files have in fact been printed more than once. They've been printed twice to terminal. Okay, so hopefully that highlights how easy it is to add a module to the pipeline template. Now, obviously your use case, depending on whether you want to use FASTQ files or not, and whether your pipeline is completely different, will depend on how easy that is, because you may need to configure the channels differently and the inputs differently. But it just shows you how you can use modules directly with this vanilla template. You can list the modules that you've got installed in your pipeline, and so this is now where we start looking at the Nfcore modules commands that we have written and made available to you by the Nfcore tools package. There's a number of options here to do various things. like creating modules, creating test YAMLs, which I won't go into much detail for purpose of time. You can lint, bump versions, and also test these modules as well. So for now, let's just see which modules we've got installed in our pipeline. And Nfcore modules list local. And so you can see the Nfcore modules that we've got installed in this pipeline are in this directory. So if we open modules, we've got Nfcore dump software versions, FastQC, and multi-QC. And all of these modules are being tracked in this JSON file. So this JSON file is how we eventually decided we would track the versioning for these different modules. You don't need to touch this JSON file. Nfcore tools should interact directly with it. It should update this file whenever you install a new module, whenever you update a new module. And so this is just a way for Nfcore tools to track what you've got installed in this particular pipeline. And then it makes it easier for you to update this and use it across time, and to also get the versions of the modules that you're using. So let's run the Nfcore modules update command. Now, this is quite nice. In this case, you'll see that you can update all of the modules in a single go. So if anything changes on the Nfcore modules repository, Nfcore tools will query the GitHub API, see what's changed, and it will just automatically update everything for you. You have the option of looking at the diffs for what's changed between what you have locally and on Nfcore modules. It's up to you. You can dump that to a file or terminal, or you can just brute force update everything. And so in this case, what it's just showing you is that all of these modules are up to date, and that kind of makes sense because we just released tools yesterday. And so we made sure everything was up to date. And since then, nothing has changed on the Nfcore modules repository. So everything is looking good here. But when things do change over time, this particular command in the Nfcore modules toolkit is actually really nice because it does it all for you in an automated way. And all you really have to do then is potentially, if any channels have changed or anything else that has changed within the module, you may need to just tweak a few things here or there to get the pipeline working again for you to be up to date with what's on Nfcore modules. You can remotely look at the modules that are installed on Nfcore modules, but this is a massive list now. As I mentioned, there's also 632 modules. And so rather than that, we've added all of this to the Nfcore website. And so there's a modules page, which you can see here, which is just Nfcore modules, where you can search for these different modules by various attributes and so on to make it easier for you to find these modules there. So now what should we do? There's the local modules. We updated the modules. We listed the remote modules. Now let's try and install a module from Nfcore modules. So if we do Nfcore modules install, say we want to install a PSP module, and that's it. So you'll notice now that FastP module has been added to this modules JSON file. So this gets updated automatically. The module itself is downloaded and added directly to the Nfcore modules folder. So you don't have to go and grab anything. You just need to tell the toolkit what you want to be installed, and it will go and grab the latest version of the module for you. You can even pin it to particular Git SHAs as well. If you want to stick to a particular revision of a module, you can even pin it to that as well. And so if we look here, this is the module that we just downloaded and installed in the pipeline. It's tested, it's fully functional. What's nice is everyone updates it centrally, and then you can use and install it directly in the pipeline. So let's now try and call FastP in our pipeline. And to do that, we need to include it. And so here you can see there's an include statement that's been printed to screen. If we just copy that out and include it here, let's remove this. Now, where we are essentially importing this FastP module or making it available to the main script, and then we also need to invoke it within the workflow. And so copying directly from the website. Let's try and run this now. So all I've done really is we're passing the same channel of reads, because this module as well just takes a meta map on the reads, and it takes a couple of Boolean values for whether we want to save the trimmed fail FASTQ files, and whether to save the merged FASTQ files. And in this case, we're not interested in those. And so for simplicity, I've just set those both to false. So now let's try and run the pipeline again with FastP in it. See eventually that FastP is now being called, and it should finish and run with that as well. I can even do modules info, info P, and that will give you all of the information about this particular module as well. So there's another way of grabbing the information about the input channels and so on for this particular module, as well as other metadata that's been added to the this meta YAML file here for the module. So it's just a nice, easy way of accessing this information directly in the terminal, especially when you're stitching these pipelines together. So now we have FastP working. Say, for example, you want to change this module, but it's a custom change and you don't want to commit that to Nfcore modules because it's something that you'll be using. And so in that case, what we can do is patch the module itself. And so say, for example, we add random echo in the script section here. We run the linting. For that particular module. What you'll see is that now you get a failure for the linting because the local copy of the module that you have in the pipeline is now different from the one that's on Nfcore modules. And that's because you've made this change. And so Nfcore Tools is clever enough to know that actually you've changed this module, but you want to use a standardized version and you've put that in the module station. So we need to do something about this if you want to keep this module in this pipeline. And so what you can do in that case is just run a really nice command called Nfcore modules patch. So what that will do is now you can see in this FastP directory, there's this FastQ diff. And this is the diff of exactly what you changed in that module. And this is a record of that, which then also gets tracked here in the modules.json. And so this allows you to make amendments to existing Nfcore modules and still have Nfcore Tools track and update everything. It knows where to incorporate these changes for you. So that's a really nice tool that gives you a bit more flexibility in terms of how you use Nfcore modules as well. You can lint all modules at the same time. I just showed you one for FastP individually, but you can lint all of them at the same time. And now you can see that that lint failure that we were getting for FastP has disappeared because we've patched this module as well. And so now we don't have any lint failures here for that. We can create a module. So if we go to Nfcore modules create, because we're running this in a pipeline repository, what we get is prompted to add a module. Say we don't want to apply on the package. I think GitHub API is broken at the moment anyway, so I won't even bother trying to do that in a demo. And then it just prompts you for other information that you can add. We want to use a meta map. And that's it. And so what you can see here is that that demo module has been created for you in this local folder here directly. It comes with a bunch of to-do statements where you can really start filling out this module. There's some best practice that we've noted down here and things to take note of. And then once you're done with that, you can remove all of these to-do statements and hopefully add this module to the pipeline. There is also another way to create a module. So I'm going to come out of here, and what I'm going to do is try and show you what happens if you now try and create a module in a clone of of the Nfcore modules repository. So all I'm doing really is cloning the Nfcore modules repository locally. And you might want to do this if you want to contribute your own modules. To Nfcore modules. And so here, this is just a clone. You'll see a bunch of modules that are all installed directly in Nfcore modules. And in fact, this is where Nfcore Tools is retrieving this information from the main GitHub repository and installing the pipeline. So let's now check out the branch, because we don't want to change master directly here. And now if we run Nfcore modules in this directory, Nfcore modules create even in this directory, and add our demo module here, what you'll see now is that more files have been edited. So when you create the module in the pipeline context, only one file is created. And so this file is created because it's a local module to this pipeline. It could be a module that you want to customize and add there directly. However, if you create, run Nfcore modules, create in a clone of the modules repository itself, you get many more files created. And this is because you're creating a standard module based on a template that we've added to Nfcore Tools to allow you to contribute to Nfcore modules. And so these files, if we quickly go through them, we might need to change directory here to modules, reload git pod. So now we're in this modules directory, you'll see all of the different modules that we have available. Each module has its own tests as well, which is why you can see a number of files have been created in this test folder as well. And so this allows you to add and fill out so if you have a main script with all of the same comments you would have had when you created it in the pipeline, you've got a meta YAML that allows you to add description for this module, various things, and this is the information that is parsed when you use Nfcore modules info. And so this allows you to essentially document the module itself, the inputs, outputs, what the process does, license, and so on. So those are the files that you can see here. If we go into the tests folder, there we go. So there's a demo folder here as well. So test modules on Nfcore demo, and there's a few files that have been created here for you. And so this just allows you to really start creating this module and filling it out to contribute to Nfcore modules. When you do contribute to Nfcore modules, it's quite important that you have tests for this particular module to make sure it's working. This allows us to do CI tests and that sort of stuff, unit tests to make sure it's working. We use PyTest workflow for that. I won't go into the details of that. I put a link at the bottom of the tutorial there that you can go and get more information for this sort of stuff. But here, the main script is essentially for the test. Is all it's doing is calling that main script for the module that we put here. And then it's running a minimal workflow to test that that module works. We have a Nextflow config file here that is, at this point, is just setting a sensible publish directory. And then we've got a test YAML. And this YAML is what PyTest uses to run this particular workflow. So you can see here, there's the command that it's using. And what's nice is that all of the output files that are produced from this particular module, we can check the integrity of these in various different ways. We can check for MD5 sums, we can check that they exist, we can check for contents and so on. And so this means that over time, as you update this module, you can track why things are changing and whether things are breaking or not. And so it's very powerful. We have these sorts of tests for most of the modules now. And it just gives you a bit more confidence as to, you know, when someone makes a change to this module, is it broken or not? And we want to make sure that it isn't. So whenever someone contributes or updates a module, that it's always working. And this approach allows you to do that. And so I think that's kind of it for me in terms of what we can offer for with modules and the functionality that we have in Nfcore Tools. it's constantly growing and expanding. We've got sub workflows, as I mentioned, coming next week. Hopefully, we're working on prototypes for that, which is partly why we had to restructure everything over the past few days. And so, yeah, stay tuned, and hopefully you're able to follow this. Apologies for switching things in between, but hopefully you are able to get the drift of everything. And yeah, thank you for attending.
Awesome, thanks a lot, Harshil. I think I can take it over from here. If
Maybe
you can pass me over the spotlight. See if I can get onto there. I think this I just noticed there was one issue there, Harshil, that there may be an issue with your clocks in the background. The time never changes, so maybe you need to get those fixed for next time as well. Awesome. Well, thanks for joining everyone for the third and final session. Today we're going to be talking. My session is going to be mostly focused on Tower itself. So I'm just going to quickly go back and share with you and go back into the environment that we had previously. So going into here, and I'm going to give you a little kind of a bit of a background on Tower first. Going to give you a kind of a demo of the application, and then kind of show you the various ways that we can use it and how it can apply to what we're doing. So kind of stepping back a little bit. So I'm going to go firstly to tower.nf. You can find this at if you type in tower.nf or cloud.tower.nf, Nextflow Tower, you'll find it. And this is the hosted version of Tower. So kind of what is Tower itself? Well, you can think of it as like a full stack web application for the management of your pipelines. And the way that this works is it's essentially a service that is in this case running in the cloud. And we can use it to launch Nextflow pipelines, but also monitor those pipelines. And increasingly so, we can think about it in terms of other applications as well. So things like the data management side of it, or the creation of the infrastructure, or the sharing of results as well. And it kind of comes together in a way which is very similar to the philosophy of Nextflow, in that with Tower, you can install it sort of anywhere you are. So it's kind of got this idea of that you can put it on your laptop. If you want, you can even install it in the cloud, you can install it on your cluster. And then separate from that is the actual computation, like where the analysis runs, basically where your Nextflow pipeline is executed. It can also run essentially anywhere that Nextflow can run. So you kind of get all the benefits of this kind of flexibility. So when you're looking at this, it may look like some sort of like SaaS application or genomics in the cloud applications, of which there's a lot of them out there. But in reality, what we're doing with this is we're actually connecting into your computation itself. So it's almost like you can think of it as like a pane of glass onto your computer itself. So Tower Cloud here is available for you to try. You can log in, you can sign in here. I'd recommend just signing in with like either GitHub or your Google credentials there for the first time. And once you do that, then you can see that there's a couple of screens you can get. Like the first thing you'll see when you log in is a list of pipelines. And particularly if you go to this community showcase here, you can see that there's like a list of pipelines which are already available. And these are ones which is sort of part of the showcase here. The way that this works is it's a little bit like GitHub or these other applications that you have for repositories, in the sense you've got organization. In this case, I'm in the organization called community, and I'm inside of this workspace, which is called showcase. And you can navigate around using this button here. So for example, I could go to the Secura Labs workspace, and here into the organization, you can see I've got these different workspaces here. The community one is available, and everyone also has their own personal one. So inside of here, I've got my own one, which is available here. So the basics of this is that if you want to set up your one, you should have your own one, which you log into, which comes from there. If you want to create your own organizations, and particularly if you are, say, leading the Nextflow efforts in your lab or maybe at your university or in your company, you can come over here and you can create a new organization. So if you go to new organizations, you can add one here, and then you can feel free to add your own one. For example, the Secura Labs one here, you can see you can sort of write information around it. You can add that information in. And importantly, you can manage team members. So you can, for example, add people into the organization. You can give them particular roles on the workspaces, as well as create kind of things like teams, for example. You can group people together to make it easier to do that. You can even have collaborators and the like. So what we're going to do to start with is just look at like kind of almost a little bit going back into the history of why this came about and sort of how this came. So I'm just going to go back now to the Git pod environment that we have here. And here you can see that this is essentially script number 7 that we have. And if you follow the material there around Tower, so we're up to the section of how to use Tower in there. We originally thought about this as wanting to be able to monitor our jobs and have like a full history of essentially our Nextflow execution in a database, also with a UI, something that we could handle, that we could walk away from and sort of monitor from anywhere. And that was the kind of whole idea of Tower to begin with. So the Tower first concept was around monitoring and tracking and being able to have a kind of a database of your execution. So the way that this works is that if you go into here, if you go onto the section number 12, so there's like getting started with Tower. The first basic one that we're going to use is we're going to run our pipeline exactly as before. And we're going to add on to the end of it this with Tower option. And what that's going to do is Nextflow is going to be submitting the task and the run information to Tower, which we're then going to be able to visualize and monitor as the task, as the job is running. And then when it's finished, we're going to know about that, and it's going to sort of let us know. And obviously, we're running very small jobs at the moment, but you can imagine that you'd be running, super long ones for this when it goes through. Now, the prerequisite for this to work is that you have to tell Nextflow like where your Tower, basically your which user you are in Tower. And the way that you can do that is to create a token. So you can create a token inside of Tower first. And then the first thing you need to just do is simply export that token. So you don't need this line here for our work, but we do need to add in here this line here. So you're going to export the Tower, the access token, and then we're going to run that. And the way you can find that access token is if you go on the right-hand side here and you say your tokens, you can just add a token. You'll get given one. For example, I could put through here if I don't have already created this before. And then you can see you can just simply copy that down. I'm just going to delete that token. So given that this is the live streaming, etc. Okay. So once you've got your token, you can just copy it to the command line. And then you can export it into here with that there. Okay, so imagine that we've got that set up. So we've exported our token. Now we can simply run Nextflow exactly as we had before. So here you can see I've got script number 7. It's going to run through our pipeline. I'm going to save this here, and then I'm just going to run this. And all I'm doing is adding with Tower. And go to the end of this line and launch this. And I'm going to jump through to my Tower instance then and have a look what's happening there. So in the runs page here, you can see that instantly it's popped up, and I can kind of see this and how this is running. You can see if I jump into this, I can see the Nextflow command line that was run here. I get some sort of basic information on the parameters, on the configuration, and any kind of reports that we have. In this case, there's no reports defined, but this is a very small pipeline. It ran through, but we can see that we get some basic information. We can follow the status of those tasks as they run. You can see that in this case that we ran, this is the working directory. There was one container. This is the container that we used. It was running locally. And here is the version of Nextflow, etc. And we can dive a bit deeper than that. We can get information on the processes, so you can follow the status of those processes as they go through, aggregate statistics on wall time, CPU, memory, etc. There's a cost database. I'll show you that later on, but that's more specifically when working in the cloud. And what's going to be really useful is the task table. So now we can very quickly find. So imagine that I had many of these tasks. I could find, for example, what happened when I ran on the, say, if we wanted to run for a sample, what happened when I ran salmon on the lung sample. I can find that here. I can see the exact command which got executed. So this is the equivalent of that .command.sh file. And I can see some execution statistics, so duration, time, and all of this is stored into a task table in the back end, which we can use here. Here's the execution log, etc. This is kind of more specified when you run with from Tower itself. You can see some metrics itself. And important to note that this could be run in a shared workspace. So this could be run, at the moment it's being run in my workspace. But if I wanted to make this available to you, I could also kind of run my pipelines there And then you could see that. And the way that you could do that is if you've created an organization. I'm going to go down now into the Sakira Labs. I've got one here, which is just a workspace that we use for testing. You can see that we're running some pipelines here at the moment. What I could do there is I could go into and actually run that pipeline I did before into this workspace, essentially from the same way, but then everyone could see it. So imagine that we're collaborating, or I want to see, when something is finished. You no longer need to tell me when it's done. We can all work together in a collaborative way. So if I go inside of here in this workspace, say that what I wanted to use was verify pipelines, I can export this ID as part of the workflow ID, the workspace ID, I should say, and then we can see that. So I'll show you how to do that. Tower's got documentation as well. So if you go into Tower Help, so Nextflow or Nextflow Tower Help, you'll find the information here. And on the left-hand side here, you can see we've kind of got the different aspects of this. So there's kind of the users and the workspace, as I mentioned a little bit before. Here's the sort of section on sort of workspace management. You can see there's kind of different aspects of that surrounds as well. You've got this kind of concept of the shared workspaces, which is what I was mentioning before, the idea that you can create that workspace and it makes it available for everybody to use there as well. Okay, what I was trying to find here is the basic thing. Let me just see if I find here inside of getting started. Okay, this one's there. You can see that there's this export tower workspace ID. So I'm going to copy that and take that into my environment here. And then I'm going to put in that same ID number that we have from before. So I'm going to take in Tower 1. Just going to jump over to workspaces and copy that ID. And paste that in there. And now every time I run, basically because of this, and this can also be set from a config as well. But now when I run this is going to be run in that shared workspace, and everyone's going to be able to see what I'm doing. So I could go back into this workspace here, see this information, and you can see in a few seconds, hopefully this will pop up, and it will show you. There you go, script number 7. And you can see that that's run. It just takes a few seconds to load there, and we can kind of monitor that as well. Okay, so that was like the very basic kind of start of Tower, and that was kind of what we sort of started with in things in terms of monitoring. But it kind of got to a point where they wanted to do something so much more powerful. It's kind of annoying that I have to go to here and kind of run from the command line. What happens if I want to call that pipeline execution and I want to run it in a way where I don't need to have a terminal open, but also where I don't even need to have this running in this location? Maybe I want to actually submit the Nextflow job. Maybe I want to call it from an API. Maybe I want to automate it or make it be able to be used as part of a service. As part of that, then it becomes a little bit difficult to be dealing with kind of the command line itself here, and sort of using Nextflow in this way. What it would be fantastic to be able to do is be able to have an execution, basically save pipelines that I can come into. Maybe I can have a user interface as well, but some way that I could essentially have Tower manage the execution piece, not just the monitoring piece. And we started with that there's kind of a couple use cases that we can go through with. So we added the ability to launch pipelines from Tower as well. So what I'm going to do is I'm going to go to the community showcase, and you should all be able to see this. If you log in, you should access this. Shout out in the Slack if you've got any issues with that. But what I'm going to select here now is going to go through and choose a pipeline that I want to run. And like keeping with the theme of the other days, now we're going to run a pipeline. In this case, we've got the RNA-seq pipeline from Nfcore that we can run. And these are like the full pipelines, which essentially there from Nfcore. If I select this one here, you'll notice that we get this like user interface. We get this kind of ability to kind of see this. And this comes about from a file which is inside of the repository there for the Nfcore pipeline that we can run through, and we can add this and we can kind of see this itself. What we can actually look at what that looks like inside of here. So I'm just going to go to the actual pipeline. So home, view the pipelines, and see the RNA-seq pipeline here. And inside this repository, you can see that you've got the information here for the schema itself. And you may have seen that, I guess you've seen that previously, but that's basically sort of something that you can do from that piece, and that's how that schema is generated. Let's go into like how we're actually going to do this ourselves, or if we want to add in our own pipeline here, not just run this in Tower. So if you want to run a pipeline itself, I'm going to go to the quick launch here. You should be able to see this in your own environment, if not here. What we can do here is, this is a little bit like building the command line for Nextflow. This is like the equivalent of building this up. So what I can see here is I've got a run name. This is a name that I could give. I could provide something some sort of informative run information here. I can add labels in, and these are labels related to maybe a project that I'm running, or maybe I want to run because I want to run the RNA-seq. I can choose a compute environment. I'll show you this in a moment. We'll cover the compute environments later, but that is essentially where the compute runs, where the Nextflow job runs, and where the tasks themselves run. And then obviously we've got the key information, which is like the actual pipeline that I wish to run. And I want to run that same pipeline which we developed over the last couple of days. So I'm going to go back here, not into the Nfcore one, but into the Nextflow IO one. And I'm just going to look for the RNA-seq NF pipeline. It's a little bit simpler, so we can see a little bit what's going on there. So all I need to do here is just copy the GitHub repository, and this is exactly like the other day when we ran Nextflow run and we put in the Git repository itself. Here I'm going to go over here. I'm going to place in the repository name, and now notice this blue circle. What that's doing is it's going to GitHub or GitLab or Bucket or wherever you have stored your pipeline there. And it's going to refine for us now all of the revisions. So here you can see this is the releases. This is also the versions. You can even put in here a branch. So if you notice that you'll see like dev and DSL2 and hybrid, etc. If I go into here, you can see that these are the same ones here. So it kind of pulls those up for us, but it also allows us to do releases. So for example, the different releases which are available here become seen here as well, and allows us to do that. So you don't need to put one in, otherwise it's just going to default on that. The next thing we've got is a working directory. This is the location in our case in S3, but it will be dependent on the compute environment that you use, where the extension of work is going to go. And then we've got profiles. And the way this works is this is going to read the Nextflow config and show us our profiles. Remember how we had like dash profile, and we could write, for example, batch, or we could write any kind of config. So this is coming from here. It's essentially passing through this Nextflow config file and showing us the profiles that are available. So you can see we've got Docker, Slurm, batch, etc. And so you've got Docker, Slurm, batch, all of these things are available there. Now, one thing to remember is that Tower is going to take care of the actual compute piece. So that we don't need to specify, again, that we're going to be using AWS batch here. Tower is already going to basically add some config for the execution piece. Now, of course, we can override that. We can add something else to it if we wish. But the default piece of saying, okay, run an AWS batch doesn't need to be done, because this is what the compute environment piece here is doing. So for the most part, this is be used more for some settings or parameters, etc. There is also parameters that you can add in here, and this could be like a JSON or a YAML file that you would have passed in. This is the equivalent of the params file option. So when you're running Nextflow, you can say Nextflow run, and then you can put like your script that you need or your pipeline that you need. And then you can say params file, and that's essentially points to like some file. For example, I could have my params.yaml, which contain that. And this is the equivalent of what's happening here. And there's a couple of other options. You can add some Nextflow config, some Tower config, I'll get to in a moment. All of these things become available. The main pieces, though, are we're giving it a name, we're adding some labels, we're choosing the computer environment, and choosing which pipeline to launch. So basic stuff. Now, when I launch this here, it's going to take me through to a monitoring screen. And what's taking place here is a little bit different from what's taking place before. So when I'm launching this pipeline now, instead of Nextflow, say, running on my local machine, what's happening is Nextflow, like the Nextflow job, the Nextflow run job, is being, in this case, submitted to the cloud, in this case, AWS Batch. And from there, the individual tasks are also being submitted into AWS Batch. So you've kind of got this batch squared approach. And the great thing about this is that we can submit the Nextflow job onto a normal instance, let's say not a spot instance. And it means that from there, we can basically walk away and we can completely kind of almost forget about our job. We can leave this running. You can see that we have pipelines which run for a really long time. Let's go and have a look at the RNA-seq one. I just triggered this off a few minutes ago, and this is inside of Tower here. So here, this is the actual full RNA-seq pipeline. You can see that we get some command line here, parameters, configuration. This is quite full. So there's like a lot of information here. If you've used any data sets, I'll come to in a moment, but these data sets are listed here. You've got the execution log, also the Nextflow log, those execution timeline, etc. Here you can see like everything that you'd see from running that pipeline if you were running from the command line as well. And there's reports, which we'll see in a second as well. So going through this, here you can follow the information, those tasks as they go through. You can see there's a lot more information when you launch from Tower. In this case, we know a lot more about what's going on. We can, for example, stream those logs back live in terms of the actual task logs as well. We have a little bit more detail on what's happening here. Here you can also go through, and if we see that this pipeline's a lot of different processes in here, you can see all of that information. We get aggregate statistics here on time, CPU, memory, cost as well. There's a database on the back end with all of the costs of all the cloud providers. So all the instances, all the regions, all the cloud providers. And what we do is we basically say, okay, how much of that instance are you using for that task? And then just sum it up over the time. So you know exactly if this task has been running for half an hour and it's using half the instance, you can take the instance costs and multiply half by half, so you end up with like a quarter of the actual hourly instance cost. And we sum all of that up. It's an estimate. It's probably a slight underestimate, but it gives you like a rough idea of how much you're spending in there. We have some work coming up next week, which we'll be releasing at the summit, which provides you the actual costs, which will place cost tags onto those jobs, so you can kind of look retrospectively exactly how much something costs. Here you can see the amount of cores that I'm running in this pipeline in real time, how many tasks are running. And then there's a memory and the efficiency of the CPU as well, which is available. Okay, going through this here, you can see the task information here. This is here, and you can see here the information on the individual tasks themselves. So I could, for example, look for, say, wild type replicate 2, and I wanted to know exactly what happened when I ran star align. So I can select that task. I can see the exact command which was run there. And I can also see the information on the execution. So I can see it ran for 2 minutes, 39 here. I can see that if we remember that each task itself is run inside of a container, here you can see that it ran inside the star container. It ran on this queue. It requested 2 CPUs, 6 gigs of memory in 3 hours. And then I can look at that. I can say, okay, well, it actually got placed on this R4 large machine type in this region on the spot model, and it costs this much. And this is how we get some estimates of those costs. We can also compare that to the actual memory that it used. So we can look at how much did it request versus how much it used. And we can start to optimize the pipelines based on that information and based on that. You can get a visualization of that when the pipeline is complete. So let's jump through now to see a completed pipeline here. So I'm going to jump through to a pipeline which maybe we've run earlier here. So it's from yesterday. And you can see here that we've got a little bit more information when the pipeline is complete. So you can see the full execution logs from Nextflow. You can see the reports here. And this is a way of defining essentially that the outputs of the pipeline that you may wish to share with people, maybe used to use outside, maybe you wish to send us an email. Here you can see we can define a multi-QC report. So you can define any HTML. Here you can see the information from that report as well. You could also open this in a new tab if you wish to and kind of see that. So here's our report. Makes it nice and easy just to find that. That typically may be in some like S3 bucket or the like. But having that information there is really useful for us as well. We also have the ability to have PDFs or any kind of images there. I can open that one up as well. And here you've just got some images which are created from that pipeline, as well as things like the structured data itself. So this is a TSV file in this case, which has been output. I can choose the delimiter there. I can search through it as well if I wish to find particular genes, open that, download that as well. What else is available when we have this? So when the pipeline is also complete, we can see the information regarding the metrics. So here is the CPU, and you can see that there's a CPU allocated or how much we've requested. We can also see the memory, and we can see like what percentage of the allocation here. And you can see that in some of these tasks, we're actually requesting a lot more memory than has actually been used by the task. In some cases, there's a minimum of AWS batch of 1 GB. So you can't really get better than that in terms of that optimization. But you can also see here on time. So if you work in a cluster, sometimes it can be beneficial to just request the amount of time that you actually need. Otherwise, you get a very kind of a low score in terms of your prioritization onto that. And you can even see things like read, write as well. Okay, I want to touch quickly before I'm going to go on to the computer environments, because that's really where some of the magic is happening and how this is all possible. But before I do that, I just want to quickly touch on the data sets themselves. And when you run a pipeline, so some of these ones from the community showcase, the ones that we have in Nfcore, particularly with regards to the input schema and the schema for those input files, you'll notice that when I launch, let's say, this pipeline like RNA-seq here, I have this ability to select the input, and I can actually just search for RNA-seq here, and I get this file and this version of this input data, which is provided to me. The way that this works is this is a way for handling data sets, in particular data sets that are sample sheets or structured data that is sort of in this structured form. Here, if you navigate to data sets, you'll be able to see this for example, Nfcore RNA-seq test. And this is a sort of description of that data set, but we also have in here now the actual file itself, which I believe is a CSV or a TSV file. And here you can see we've got the sample ID. In this first column, we've got the FASTQ1 and the FASTQ2. And there's also some metadata around how that how that would be processed now. And what it's possible to do is by uploading a data set here, and from that data set, then you could use it as an input to your pipeline. And the kind of way we were thinking of the sort of direction that this is heading in, and I'll point out another fantastic little tool that was developed by Phil, who was speaking earlier on the SRA Explorer. The concept here is that we are able to find data sets, essentially metadata, and from that we can import them into Tower. So for example, if I was to search for some samples themselves, I could find these particular samples that are here. I could select them, for example, create a data set itself. And from this data set, I end up with this TSV file here. This is an idea where we've got the identification of those. And the important thing is that we've actually got the file itself. So here you can see we've got some FTP, or we've got the SRA, which we could also use. We've even got the ERA identifier here, which can be used. What I can do is I can download that TSV file. And inside of Tower, and you can do this via API as well, I could, for example, upload that into here. And then by selecting this first row as a header, now all of a sudden that could be the input of my pipeline. So we've kind of gone from this very quick way to find data sets to construct a sample sheet, in this case from SRA, and then it could be used as an input to your pipeline. Now, it's important to remember that for this to work, your pipeline itself, the way that you write the pipeline should match up. So you would have to say that accession is the ID, for example, and that you want to use SRA URL as your file identifier. But that could be fully processed in parallel, and there's some tools for doing that, which is part of the Nfcore pipeline for downloading fast queues, etc., which you can see. Okay, so that's a little aside on data sets. We're looking to evolve this quite a lot as well, and sort of continue going down this direction for helping people out. With regards to the compute, so far when I launched this pipeline, I didn't really mention it too much. I basically just launched in that environment. I'm going to just switch case to a workspace that I have here for my verified pipelines. And here I've got, when I go to launch a pipeline, it's exactly the same. I've just got some more compute environments set up in this one. When I go here, I can select, for example, let's say I want a pipeline to launch. I'm just going to select the same RNA-seq pipeline for us now. I can now choose a compute environment that I want to launch this in. Notice how my work directory here is S3 Paris. It's because this compute environment is tied to that bucket. And ideally, you want your compute and your bucket in the same region. In fact, I think it's mandatory. What we can do though is we could select that we want to run the same pipeline. Maybe we want to run the specific version of this pipeline, and we want to run that now not just here, but if I want to run that now on Azure Batch in East US, completely possible. And you notice that now my working directory is updated. Likewise, I could run that on my Slurm cluster, so I could connect into my compute resources that I have on premise, and Tower will submit the Nextflow job onto those resources, and I'll kind of get all the benefits of using Tower there. So this makes it possible then to kind of connect in any of this compute, and the way that this is done is by setting up these compute environments themselves. Setting up these computer environments is typically a one-step process. It's sort of something you do once, and this can be defined from these computer environments themselves here. So when I go to look at this pipelines here, I've got these computer environments here. You can see I've got Slurm set up, I've got Azure Batch, I've got Google Life Sciences. When you create these, you can add a computer environment here. And when I add the computer environment, I can look at here the actual platforms. So we have support for Amazon Batch, for Azure Batch, for Google Life Sciences. We also have the schedulers here. So this is the main one for Altair, for PBS Pro, for Grid Engine, LSF, Moab, and Slurm, as well as for Kubernetes. And there's like specific executions here for EKS, GKE, and Kubernetes, sort of the normal version there as well. I'm going to show you through like what it looks like to create this for Amazon Batch, and then we can look at one for the schedulers. They're quite similar between them, let's say. So with Batch, we've got a lot of options on how we can do this. The minimal requirements are to have some credentials, to choose a region. I'm just going to choose, in this case, let's go with Singapore. And then from here, I can choose a working directory. This is going to show me all the S3 buckets that are connected to those credentials. Now, as I said before, you should select here a bucket which is set up, which is basically set up for that region. And the other thing that I'd recommend doing is that if you're going to use this as a work directory where you're just using it for caching, and that maybe after 1-2 days, maybe 1-2 weeks, you don't need that data anymore because you've moved your data with published somewhere else, then I would set up a policy on that bucket. So I would set up a policy that says after 1 week, delete that data. And this way you don't end up with a lot of cloud costs with regards to storage for temporary files, which can be removed. So here is I'm setting up a bucket, I've set up the region, and then I've got a couple of options. I can choose to do a forge mode, which will create everything for me. So this will create me a queue, compute environment. I can say I want 1,000 CPUs. And essentially set that up, and that's kind of good to go from there. If I create that now, that will add all those resources in that environment, and Amazon Batch will be available for me. One thing I didn't point out is like the credentials themselves, they need to have particular permissions. And if you go into the credentials section here, when you add the credentials for the provider here, so if I want to add the AWS Batch one, you can see that if I wish to do that, I should have these permissions here. And this is a description of how you can add those permissions. You can see the exact policy which is required. So if you're familiar with AWS, you can just copy paste this into a policy and make sure that the user has those permissions. We have full instructions on how to do this into Tower if you're unsure on how to do that. That creates that computer environment, makes it available for people to run. If you want to connect in with your, say, your Slurm or your on-prem environment, maybe you've got Grid Engine. Here you can set this up, selecting the platform that you've got. So in our case, let's select Slurm. And in the way that you can do this is you've got two options for connecting into your cluster. You can use SSH, which is in which case you provide to Tower the SSH key, and that Tower will then be able to essentially log into your cluster and do the Nextflow run piece. Or you can use what's called the Tower agent, and the Tower agent is this little piece of software. It's a little tool which runs on your HPC cluster, and from there it allows Tower to connect back out to it. So you can simply run this in here, run that little agent, you put the connection ID in, and then Tower knows essentially the agent. It's more, instead of Tower connecting to the agent, to the cluster, it's more that the agent connects out to Tower, and you get that connection, which is caused, which is in this way. The rest of the options are very similar here, except obviously you're not specifying the resources now because it's actually Slurm that's going to be doing the execution piece. So you specify the work directory for that execution. You specify the launch directory. This is where the Nextflow run command is going to take place. And then if you're going to be using SSH, you've got the username. This is the username on the cluster that you have, the login name. So this is basically the location of where you're going to be logging into. And if you've got the ports, which are optional as part of that. Here you've got two options. You can put the head queue in, which is where the Nextflow job will run. So typically where you'll set that up is that Nextflow will run on a head queue, and then you'll have the compute queue, which is where the actual pipeline jobs. And this can be overridden by the pipeline configuration as well. So again, once that's set up, you have the pipelines here. You can do a quick launch. Let's say I'm going to select that I want to run that same thing in Slurm. I'm going to choose my pipeline that I wish to run here, and I want to kick that off, and it's good to go there. Okay, other aspects which are important here is that inside of all of these, let's just go to another one. Let's go to some testing pipeline here. Inside of here, the permissions boundary for all of what I've shown here, the launching, the running, data sets, etc., is driven inside of this workspace. So inside of the workspace here, this testing workspace, for example, there's participants, and those participants have different roles. So here you can see that we're all admins because it's just some development testing environment, but I could also be an owner. I could be an admin, which is basically full permissions. A maintainer is someone who can add new pipelines and change the settings of those, but they can't add compute environments. A launcher is someone who can launch pipelines which already exist, which are available there, and a viewer is kind of a viewer in itself. So those permissions are kind of defining that. The other important things on the kind of setup side of this, you can add in credentials here. Those credentials can link into, for example, AWS in terms of the cloud providers. You've got the source code management. So this is how you're connected in to run private repositories. Maybe you've got something in GitHub, which is in a private repository. You can add your GitHub credentials in there to do that. There's also support in there for SSH, for Tower Agent, which I mentioned before, for connected into that as well. Other aspects of this is you can think of credentials as like one piece of like almost like the configuration of your infrastructure, configuration of the Nextflow job piece. Often you'll have what we call secrets, which are maybe API tokens or passwords or keys that you need to use to access, and they're used inside of the pipeline. So maybe they're used by a tool inside of that pipeline. An example of this I can show is that in here we're running Dragon, for example, and we've got the Dragon password and the Dragon username is stored in here and in the secrets section. We also have a license for running Sention. We've also got an NCBI access key here. And by having those things as secrets, if we go into the Nextflow secrets here section, we can either reference them in configuration or inside an actual process. So there's a new directive called secrets, which allows us then to have a placeholder for that secret. And what happens is when Tower runs, it will place those secrets into a secret store. So within AWS Batch, there's a secret manager, or if you've got something, it will be a variable in your HPC. And that means that the secret itself is never actually like stored in the code or never stored in the logs. And it means that you can get this essentially handling of these secrets without actually having to publish them anywhere as well. It can be very useful for those kind of applications as well. Okay, I think that's the kind of the main pieces with regards to Tower. As I said, this is a lot of development. I should point out as well, one thing that starts to become quite useful is around automation. And so far, I've shown everything from the user interface. Like I've been launching these pipelines, creating computer environments or workspaces, etc. What is more useful, though, is to consider how we can think about actions here. Actions are a way to trigger a pipeline based on an event. And we've got a couple of events that are available here. And there's a GitHub hook here. So if I commit to this repository here, this will fire off the execution of the pipeline based on these settings. So this is a way to trigger the execution of a run based on the commit. And you can imagine this would be useful for like CI, CD settings where you maybe want to test the release of a pipeline, make sure it's actually running against like a full data set in a kind of full distributed way. Things like GitHub Actions are great, but they're not designed for doing really long running, heavy lifting jobs. Then you've also got RNA-seq launch hook here. And the way that this works is that there is creates an endpoint for you. So I create a pipeline essentially, and I define the webhook as the action. And what happens here is it's when it submits the pipeline essentially. If I hit this, so if I copy paste this, I believe this should actually work. If I place my token inside of here, this will launch the execution of a pipeline. This is a really great way of connecting Tower to other elements. So basically, if you want to launch a pipeline in Tower from some other environments as well. What also can be great is considering that if you want to do this whole thing from the API. So this is like an easy endpoint into the API, but the full API is also published as an open API. And if you go into here in the standards here, sorry, in the settings here, if you go into the endpoints, you can see everything I've described. So actions, computer environments, credentials, launch, org, etc. All of that is possible to do here from these endpoints, and this makes it super flexible. And there's a lot of people who are building, like a lot of organizations who are building on top of Tower, so that maybe they're building their own vertical or very specific front end that they wish to use, and they're kind of using Tower as a kind of back end management service for the pipelines and for other things as well. Other aspects of that is that there's also, I should point out, a Nextflow Tower CLI. And this is extremely useful for situations where you are, let's just go here, where you want to, for example, you're comfortable with using the command line, but you don't want to, you still in some way want to have all of the benefits of Tower, of it running remotely, having access to all of the information afterwards, the logs, the automation, etc. And instead of writing Nextflow run, you can use this new command line tool, and it's called Tower. So you can say Tower launch. You can, for example, list the pipelines that are available inside of your workspace. You can see the actions. What it's I would say even more useful for though is setting up the infrastructure, setting up the research environment. So with Tower here, you can define, for example, and you can import and you can export pipelines. So all of this showcase here, all of these pipelines are actually defined in the Git repository. And we just use the command line. We say Tower import, Tower export, all of these environments, so that basically we can set up this whole thing completely reproducibly in a kind of fully kind of automated way as well. So that allows you to import, export these things and really just kind of deal almost like with an infrastructure as code like set up for doing that. So I hope you got a kind of good flavor of that. The model for this is that there's Tower Cloud, which is available here. And we also have Tower Enterprise, which is mostly focused on organizations that want to install Tower in their own environment where they want professional support and the like. And that's kind of what we offer as part of Secure Labs. But I'd recommend giving this a try. So you can just log in with your GitHub. If you've got any questions on that as well, put them in the Slack. There's also a Slack channel in the Nextflow Slack as well, which is available, which is under Tower Help. So if you've got any questions with that, feel free to ask them. My time is up. I think our time together is up, but I'd like to thank everyone for taking part. Also, thanks a lot to the instructors, particularly Chris and Tashel and people who've been getting up at 5 o'clock in the morning here, or 4 o'clock in the morning in some cases. So it's been fantastic to have you all on board. Did you want to come and say something? Come and say some final words, Chris? Otherwise, I'm happy to pass it all now.
No, I think you covered it nicely there. Just my really warm thanks as well to everyone for attending, and just to make sure, I really encourage anyone who does have questions just to dump those in the Slack. It's a really great community, and someone will get back in touch with you really quickly. Sorry, I think Evan might have been on spotlight for all of that, but hopefully everyone heard me.
It's natural. Awesome.
Thanks so much, everyone. I really appreciate your time, and do stay in touch. I look forward to seeing you around the community.